All right, welcome everybody. It's 10:30. We're going to go ahead and get started. This is The Future of BIM is Not BIM, and it's coming faster than you think, the sequel. Just curious, show of hands who saw the first Future of BIM is Not BIM 3 years ago. Okay, great, about 50% of you. This one's not going to be as good, so I'm just going to let you know that up front. Sequels are never as good as the original, except for Ace Ventura, in my opinion. But you guys also know, like right now is the general keynote, right? It's like, okay, Autodesk CEO or this bald guy up on the stage. So there's probably more interesting stuff. I'm just teasing, but it does mean a lot to me to have such an awesome turnout, considering that the general keynote. So sincerest, thank you very much for coming here. I don't know how I got that short straw. They're like, all right, let's put them in the same slot as the general keynote, but it does mean a lot to me that you guys are here. Just a little bit about Evolve Lab, just in case you're wondering who we are. We're a collective group of misfits that just really geek out about technology and computation and design and things like that. And I think I saw Ben. Ben, are you here? I just thought I saw you. There's Ben on our team. He's here in the house. Represent. So he's here. I wanted to start off with a quote, though. So it says, France Willard says, "The world is wide, and I will not waste my life in friction when it could be turned into momentum." And so I'd like to start off with the story of my own failure. Most people like to talk about the things they're good at. I'm going to share what I'm not good at. So I was working at an architecture firm. I was a BIM manager, and we had been using this space planning programming tool. And for purpose of courtesy, I won't share what the name of the program was. But I thought it was the coolest program. It was taking programmatic information, departmental adjacencies, and then you could factor in all of this information, floor area ratios, net square feet, all of this information, and then you could port it over to Revit. And so there was this data porting that was happening from one program into the next. And I thought it was just like the coolest bee's knees, like the latest bee's knees, just such a cool program. And so I decided I was going to implement it at my firm. At our firm, we had a group that was doing the equipment planning and the programming, and we did the training. I sat in on the training. I continued facilitating it for a while. And after a while, I just started getting some really bad complaints about the program. It's very archaic. It feels like it's 1996. You have to hit this refresh button every time you make a change. It was just a really bad user interface. And ultimately, our team despised me for implementing this new tool. And so the point being of the story is that I had failed in implementing a technology. And I was wondering, like, why? Why did it fail? What was the issue? And it really comes back to Francis's comment about reducing friction. And ultimately, as it relates to where we're going as the future of BIM and as an industry, it's the idea of mitigating and reducing friction. And so hopefully you'll see that as a theme. So what are some examples of reducing friction? So just show of hands, everybody familiar or have used Dynamo before, right? Great. Which I love. This is cool because we're in what I call the tool building age. So no longer are we waiting for the next Revit release to fix our stair railing tool. We can start kind of building our own tools, which I think is pretty rad. And so what we've done is, you have Dynamo, which I love Dynamo, by the way. The idea of visual programming, and then you have Dynamo Player over on the right, which has less friction, right? If someone on your team or at your firm opens up the left, or if they click on the play button on the right, it's mitigating and reducing friction. So this is just one example of that. As an example, DataShapes also has some great packages of being able to start building in different UIs. So this is an FF&E sheet generator that produces your FF&E sheets using Dynamo and the DataShapes add-in. And so just kind of further mitigating and reducing some of that friction, right? So as it relates to everyday technology, I read this article and it kind of blew my mind in the sense it was thinking about how different technologies, I think we kind of compartmentalize ourselves from entertainment and how we live the rest of our life, or at least I do, and then my professional life. Certainly, like, this technology doesn't apply to architecture or construction or engineering. There's no way that could apply. And so I want to ask a question as it relates to even challenging myself in some of these presuppositions. I want to ask how you consume music. Is it different from 5 years ago, 1 year ago? I think about, like, I remember, I'm from Omaha, Nebraska, and there we had this place called Homer's. And you would go to the Homer CD store, and you would go through, you would have to get in your car, drive to the car, drive to the music store. You had to go look through all the CDs in alphabetical order. You had to find the CD, go to the counter, buy the CD, bring it home, put it in the CD player, and then listen to the music, right? This is pre-internet. And then post-internet, does anybody remember CD Baby? They were hot for like 2 years. Like, it was pretty cool. You could order your music online. Like, this was like so cool. You didn't have to drive somewhere. You could just order it, and then the CD would show up in the mail, very convenient, and then you could listen to your music. What do we do now? Hey Google, play AC/DC. Hey Alexa, play Blink-182. And then the music plays it. It reduces the amount of friction that occurs from the process. This is the journey. And there's this disruption that happens. So I want to ask, can voice technology apply to our industry? And I want to highlight a good friend of mine, Ryan Cameron, who used an Alexa and plugged it into Project Fractal, which is now Refinery.
Alexa, find the hotel options with greater than 25,000 square feet.
I have 426 options of greater than 25,000 square feet. Can you go less than 25? I can show you more options.
No. How many parking stalls does the first option have?
All right, option 1 has 355 parking stalls. Are you interested in any other options?
Yes. Show me option 10.
Okay, option 10 has 375 stalls, 25 more than option 1.
Good. Please remove any options that have less than 375 parking stalls.
Okay, so the point being is, I don't necessarily know if I'll have an Alexa sitting in my cubicle helping me drive design, but it really challenged my thought and process to think about, can these kinds of technologies really start to introduce themselves into our general practice? Now, there was this thing that I realized earlier in my career of what I called the data drop chasm. And it was this idea of, like, why do we continue to recreate the same data or the same information over and over again in different programs? I continued to notice this data drop chasm, and specifically in the model drop chasm. And I was super anti-SketchUp, by the way. Like, full disclosure, some of you guys will agree with me, some of you guys will punch me in the face afterwards. But I was very anti-SketchUp as a BIM manager because I saw like this waste. I would create something in one program, and then I would have to recreate it in another program. And often I was the recipient of having to recreate that geometry. I was inheriting a lot of these models and having to recreate this information. And so we start to be able to overcome some of this model drop chasm, say between the format tool and Revit using the exporter. It comes over as materials, but it's still a mass. And so then we started to think about, okay, SketchUp's pretty hot. Could we start to create a building information model from a SketchUp model? So being able to assign walls, doors, windows, roofs, curtain walls, etc., and have it be a firm's native content. So it would be their window library, it would be their door library, etc., and be fully schedulable. And so assigning that data to the SketchUp model and then porting it over to Revit, avoiding this model drop chasm. Further, we were contracted to do a project recently using Rhino inside. And so for those that don't know, it's the idea of using the Rhino Grasshopper interface, the visual programming, and then porting that information over to the Revit model, again, as native Revit floors and native Revit curtain wall. And so this is another example of this. We really wanted to take this even to the next level, which we're doing right now, and starting to bring the information, say, into Assemble and Microsoft BI for data visualization. And so there's some really good opportunities to overcome that model drop chasm that exists. But there's not only a model drop chasm, there's a data-driven chasm. In The Economist, they said the world's most valuable resource is no longer oil, but data. And I want us to just sit on that for a second. I want you to think about if you were going, let's say that you're going for a hike and you have your dog and you're walking down this pathway, it's a beautiful sunny day, and the dog veers off the trail and it goes into the bushes, and you call the dog and it doesn't come, and then you go over there and there is this massive nugget of gold. Okay, and you look at it and you're like, oh my goodness, like this is probably $500,000, $600,000, $800,000 like in just gold sitting here. And then you go, okay, Sparky, let's go. And then you go walk off, and then you leave it there. That's similar to what we do every single day with the data that's in our models. So if data is more valuable than oil or gold, how are we consuming the data? How are we using the data? How does it inform our decision-making process? So how do we consume the data? Primarily, we consume the data in rows and columns, okay? Like if we say, oh, well, we use data, how do you use, well, I created a door schedule. I created a sheet index. I created a clash detection report. And so you have this data that exists in rows and columns. And it's tedious. You have to scroll and scroll and scroll and try to find this information. And wouldn't it be freaking cool if you had a more intuitive, dynamic way to interact with data? And so Ben on our team, who raised his hand, has been helping Evolve Lab develop what we're calling our dynamic dashboards. And so it's the idea of starting to have not just static pie charts or static bar charts, but actually starting to have dynamic information driven by physics engines to be able to help drive design and not only have information live outside of Revit, but live directly in Revit. So on the left, we actually have information you can see as walls are drawn or content is populated. It's updating in real time in a sundial. And further, the example on the right has a departmental adjacency matrix. And so it's the idea of, okay, we have these clusters of departments and data, they're supposed to be close to each other. How do we start to interact with this information? And further, how can it start to inform or drive our design? So these are some ways that we're starting to do, and this is native within the Revit interface. But then also trying to figure out, okay, for project managers, being able to say clash detection trending, punch list, if you wanted to start seeing project profitability, et cetera, being able to have a one-stop shop dashboard to be able to consume that data would be very, very useful. At least I think so, but I'm kind of biased. So this is some of the ways that we can start to interact with data, but there's still a few challenges as it relates to how this is how we consume data, but there's still a few challenges to how we interact with the data. And I want to talk about the problem of passive design for a moment. So passive design, for those that don't know, is a human, or in this example, a bald human, plus one computer equals limited options, okay? So as an example, I used to design hospitals and stadiums, and we would have, say, 21 options for a hospital, and then each option had a sub-option, option 17A, 18B, 11C, etc. And guarantee me, this was not the best option. Like, it was me trying to think about, okay, this is how many hours I have in the day, and I'm just cranking through creating space plans. Probably not the best option. So computational, you have still a bald human, plus the idea of internet or algorithmic modeling equaling thousands of solutions. Now, we still have to consume these options, and maybe we don't want all these options. We want only the optimized options, right? And so right now we're in what I call this messy middle phase, okay? All of this stuff is happening, but it's happening very, very, very fast. And there's really nothing so far that has been really helping us productize or streamline some of that process, right? So what we have is we have the building information modeling on the left. We have on the right, we have building information optimization, or automation is also a really huge value. And then we have this messy middle of visual scripting, dynamo scripting, helping us with this process, or Grasshopper if you're a Rhino user. So this is an example of just kind of brute forcing some of these tools. This is a Harley-Davidson project in Parker, Colorado, back in my backyard. And so we have this project where we were going through and rationalizing the steel facade. We had a certain budget for the facade, and we needed to be able to make sure that we did not overstep that budget, okay? So what we did is we were able to grab the linear foot of said tube steel times the cost, giving you your aggregate total, okay? So up at the top is your itemized, and then the one below is your aggregate total. And so this is one way to brute force some of these tools and help us to start using the data inform design. Another trend that is currently happening is optioneering and generative design. And so some of you guys have seen me use this example, but I love this example, and I want to ask the question, how do you design a pizza? Okay? In Colorado, and I think in other parts of the United States, they have this place called Mod Pizza. Does anybody have a Mod Pizza in their city or state? Yes. Okay, so you guys can resonate. So this is my family. We love going there, mainly because we all get our own pizza. And so my wife is gluten-free, dairy-free. She's the no sugar, like super healthy. And I'm like, give me all the processed meat and the peripheral cow pus, as she calls it, which is cheese. And so, and it's like, I love to go there because we all get our own option. Our pizza is optimized for us. She gets her gluten-free, and I get my heart attack pizza. I'm sure it's going to give me diabetes in a few years. And then our sons, they don't want all the veggies, they just want the pepperonis. So everyone gets their own pizza. So what I did is I optioneered a pizza. And if you guys are asking if I modeled a pizza in Dynamo and pushed it to Refinery, I did. This is how much of a nerd I am. I'm just like, oh man, maybe I could model this up in Dynamo. And so this is Project Refinery. This used to be Project Fractal. Fractal is now gone away, and Refinery is the new tool. It's transitioned to this. It's online. And so you can publish this information. You can also have the standalone, as I understand it. And so through here, what I'm doing is I'm optimizing my pizza. I can have different sizes of pizzas. I can have certain number of slices. I can have pepperonis. I can have no pepperonis. I can make it gluten-free, not gluten-free. And so these are some ways that we design pizzas, okay? But the question is can you apply some of these same principles to a building? So again, this is a project that Ben was working on for a client of ours. It's Hobbs Trail by Huff Design. And so they had these structures, and basically what we needed to do is we needed to optimize the structures to have typical tube lengths, typical connections, and we wanted to make sure that it was efficient for the fabrication and the people that were doing the installation of these, okay? So we wanted to, that was kind of the optimization exercise. So in the top left, you have, your parallel graph chart, and you can basically chart it how you want it, and then on the right, you have the scatter plot as well. And so this was one of the structures, and this is the second structure that we were optimizing. And so we go through, and it allows us to interrogate and investigate multiple options, multiple iterations, but not only that, we get to optimize it for the fabrication to make sure we have typical lengths, typical connections. We can change it from 2-inch to 4-inch to 6-inch just by changing the parallel graph chart. We also were wondering, could this technology be applied in other areas? And so we recently worked with Mortensen Construction, and they wanted to be able to optimize solar. And so they do these massive solar fields, and we were like, okay, could we optimize solar to be, say, highest density solar panels for the least amount of money with the highest power loads, right? And so we started working with their engineering team in building out basically their own refinery. This is their tool, and it was designed specifically for solar panels and for their engineering group. Now I want to talk about generative design versus generative modeling. I feel like generative design is one of these buzzwords that often we don't see a lot of fruit, okay? And so want to say, is there opportunities for some of these tools, or is it just another catchphrase or buzzword in our industry? And so this is another one that we built for an architecture company, and it was the idea of doing test fitting directly within Revit, okay? So you're not having to go out to a third party, but directly in your space, you can put in your floor plate, you can put in your unit mix ratios, how many 1 bedrooms, 2 bedrooms, 3 bedrooms, and it would be able to generatively model some of these examples from a unit configuration standpoint. Has everyone heard of testfit.io before? This is catching up quite a lot. Good friends Clifton and Ryan over there. They've designed a generative design test fitting tool for multifamily, but they're also getting into street design and other commercial spaces as well. In here, you're able to maximize floor area ratios, net square footages, percentages yields. It's really deal making for generative design. And so I'm very, very fascinated about this technology because it's starting to have some of these kind of niche opportunities within our industry versus, say, just a dynamo script. The other thing is it's the idea of like co-authoring with the computer. And so you can see that even though it might have come up with a few options, you still have direct influence on that design by being a part of the process. I'd like to take a moment just to re-say that because I think a lot of people are worried about a lot of these tools. Well, it's going to take over my job and then I'm not going to have the work. But you still are involved in the process. It's just helping you do your job better and faster. The other comment I want to make is that a few years ago I was talking about a lot of these tools are very kind of ad hoc, and what we're going to start seeing is all these kind of niche programs. So whether it's a test fitting tool or it's a dashboard for solar design, what we're starting to see is more people moving into more of a niche environment specific to the problem that they're trying to solve or the opportunity that they're trying to create. Someone else that's doing this really good is Brett Young at M2 by AI. And so what they developed was a training sequence resulting in optimized AI solver that after 12 hours of computing and 1.2 million design coordination iterations, it finds the optimal layout bank for all of the ductwork, the pipe, the fire protection, etc. And so you start seeing opportunities where AI and machine learning can start playing a part into our design process. So it's not just something that becomes marketing, or maybe we'll get there, like this is happening right now as we're talking about it. The other trend that we're seeing is this idea of evolutionary problem solving. Okay, so we've talked about optioneering, we've talked about generative design, we've talked about refinery. But what about letting the computer help us solve problems? Is this something that could exist? And so we were contracted to work with an architecture planning company over in Dubai. And they had these podiums, the site, and the idea was could we maximize the efficiency of retail, office space, being able to have the views, etc., information within that model and optimize it. And so in this example, we're going through and using Galapagos to help us as an evolutionary problem solving. And so this one is allowing, you set the variables, you set your maxes, you set your mins, and you go through and then you can optimize your design and your variables based on whatever goals or outcomes that you want for said project. Now, this is all great, and you might be saying, cool, Bill, great for designers, great for people that are working at an architecture company, but like, what about the construction space? I'm seeing, I don't know if you guys have seen this, I'm seeing more and more contractors picking up more and more services. And it's a lot of us in the architecture world will go, hey, I don't want that risk, I don't want that liability, and GC goes, cool, I'll take that one, and I'll take this one, and I'll take that one, and I'll take that risk, and I'll take that service. And a good example of this, I remember I was meeting with the GC, and they were like, hey, here's the VR headset we're using. And I'm like, cool, and like I put on the VR headset, and I'm looking around, and they're like, yeah, here, you can pick on this finish and that finish. And I was like, how are you guys using this tool? And they're like, oh, for like interior design. Really? As a general contractor? Yeah. So, and tell me about that. Well, we have interior designers on staff. We have the owner come in, they put on the VR headset, and then they pick out all these different materials. And I was like, wow, this is fascinating. I thought the architect and the designer had already done this. And they're like, well, we just see more efficiencies as we're bidding on the project. We can find, do pricing and things like that. So we're doing that. And I was like, wow, that is really fascinating from a construction services standpoint. So contractors are seeing a lot of opportunities to start leveraging these technologies, and not only that, for computational design. So think of traditional ways that you do lift drawings or pour sequencing. Think about if you could start to optimize for some of those kind of scenarios. And so thinking about some of those opportunities, there could be some really great opportunities to leverage generative design and computational design. Further, I think everyone gets really nervous about the labor side of it. It's like, well, the machines are taking our jobs, but frankly, we're not keeping up with the demand. And so according to the US Bureau of Labor Statistics, there is about 300 vacancies in the construction industry as of this June, and it's expected that we'll need 747,000 more by 2026. That's the shortage. That's the vacancy. That's the need has far out exceeded and weighed past what we can keep up with as far as how much work there's available. Now, when I started my career early on, I saw the way that we were designing buildings, and I saw the automotive manufacturing process, and I was like, how come we can't apply some of these same techniques and principles that the car manufacturing industry has used and apply it to buildings? And a lot of the feedback I gave is like, well, Bill, it's not a Toyota Camry. Like, you can't just put it on an assembly line and run it through. And not all buildings are new. Like, we do renovations. So you can't just always apply, these kinds of principles to the building industry. So those were the challenges that I had heard. But as many of you guys know, like, LiDAR scanning has really taken off right now, and the idea of doing as-builts. And so we started a sister company where we do these laser scans and photogrammetry and construction progress. Frankly, just because I think it's cool. It's really just selfish. I'm just like, I've done so many of these, and I never get bored of looking at them and interrogating them. It's absolutely fascinating technology to me to be able to capture everything. Further, I've also been the recipient of, okay, go measure this building, and I go back to the office. I don't know if anyone else can relate. You go out, you measure, you go back to the office, and then you start drawing up, and you're like, crap, I forgot to get the windowsill. I got to go back, drive out to the site, or then you start drawing it up, and then the worst is like you have a bust, and is it a 7, is it a 4, I don't know, neither is working. You got to go remeasure all of it now because which dimension is wrong. And so being able to leverage some of the LiDAR scanning, the photogrammetry scanning is also getting very, very popular, and it's only going to pick up momentum. So then could we start merging some of this information, some of this technology, and applying it to the construction space, right? So we're working on a project right now, and we're basically doing a module. No panel in this project is the same. Every single panel is absolutely unique. Every frame is unique. All the connection points are completely different. I can't share the project because we're under a strict NDA, but I'm hoping this time next year at AU I'll be able to share it with you guys. But we have this project, and it's what we're trying to do is how do we start to compartmentalize, rationalize, and start to use the same kind of principles that we used in the car manufacturing space and apply it to the build space. And the way you do that is with modular construction, because no, not the entire building is the same all the time on every site. But there are pieces of it that can be standardized and repeated. And so that's the whole idea behind modular construction. And so throughout this process, what we're able to do is have a set of frames, a set of panels. We imply the data, the panel ID, the frame ID. All of that information is directly within the model and then gets inputted into the Revit project. And then we're able to harvest all of that information and assemble. But then also, what if we could start applying computational design to some of these ideas? This was another project that we worked on. It was for someone in the modular space for units. So every one of these colors represent a unit, and then we took that system, that framing, that structure, and applied it as part of this computational process, and then could design, iterate, design, iterate, design, iterate, design, iterate, and then be able to come up with the optimal design of whatever it was for, say, if you wanted 2 stories versus 6 stories versus 8 stories. being able to flatten it out, it grows taller, it grows wider, and then it's applying the same modular concepts to the idea of computational design. Further, what we wanted to do was to be able to apply QR codes. So like once you have that information, it needs to get assembled in the field. So we wrote a dynamo script, and you're able to publish the dynamo script. It runs and creates a unique QR code for every one of these that then could have an adhesive sticker and placed on the panel and then installed in the field, so that way they know exactly where each part goes. Think of it almost like an IKEA for buildings. And so it's trying to be able to have this information, and then they can bring it out to the field and be able to assemble it. We just finished a roundtable in the room across the hall, and they were talking about one of the challenges with some of these processes is like, well, how are we going to assemble it? We've never done pre-manufacturing and modular construction, and so the risk associated to that. And so the less, again, the common theme here being friction. How do we reduce and mitigate the friction that exists and make it more intuitive? And this is one way that we can do this. Another example is Katara, of course. These guys are absolutely crushing it. And so they've really taken this idea and scaled it into their operation. And so they have the warehouse. It never rains in there. It never storms. Construction can go on 24 hours a day. And then you're able to ship this and palletize all of your projects, ship it out there. One of the challenges of this is shipping costs and trying to accommodate some of that. But the trade-off as far as having like an environment where you can always build and to start applying some of these industrial technologies to the built process is super, super valuable. Personally, I'm geeking out about it just because I'm a dork, but I think it's cool. We're working with a few people in the ACM metal panel manufacturing space, and I absolutely have been astonished by what the team has been doing. Like the idea of being able to start applying computation, automation to the materials world. Okay, so we talked architect, we talked MEP, AI, designing your chase spaces, things like that. We talked general construction. What about the material folks? Like, what about people that are dealing with glass and curtain wall and ACM metal panels and brick, and how does some of the material industry benefit from some of these cool technologies? So this is one that we were using a similar process that you guys saw before is the rapid prototyping and facade development. But then we didn't want to just stop there. What we wanted to think about was, okay, how could we start to apply rationalization and a bill of materials? So again, the data piece of it, the data being the valuable piece. So it's consuming all of the panels and could create a bill of materials for every single panel, understanding what the panel idea is. Further, we could go through a panel flattening and a panel rationalization process in real time. So like as you're going through, whether it's a curved surface, a straight surface, it could go through a panel flattening process as well for the material space. So there's some huge opportunities on the computational side of this. And then from a packing algorithm, being able to say, okay, how do we optimize for shipping? Okay, we need heavier products on the bottom, lighter products on the top. How do we algorithmically do that? And how do we take a building envelope and then start applying groups and categories of that information for shipping? And then also trying to take into account scheduling and cost and all the things that go along with the entire shipping and procurement process. And so these are some of the problems that we're trying to solve. The other side of it is for fabrication. We were working with an electrical contractor, and basically you have your conduit runs, you have your unit struts, you have all of this information. And how do we currently create fabrication drawings? Well, typically it's an AutoCAD. You draw it up, you dimension it, you drop it on a sheet, you elevate it, and you call it a day. And so what we wanted to do is, okay, was there opportunities even in that space to start automating the fabrication process? And so we started writing some of the dynamo scripts that would basically harvest this information and be able to take the components, take the geometry, drop it on the view, auto dimension it, auto tag it, place the ID, so the ID, the panel ID, all that information resides directly inside the title block, and then be able to dimension it and print it for the shop floor or send it to PDF or whatever tool of choice you want to use for sharing that information. And so being able to auto document that entire process. Now, it was interesting because this specific client was outsourcing a lot of their drafting work overseas, and it was really hard to keep up. There's so much construction, there's so many projects, and so it was really challenging to keep up with all the projects. And they were estimating that like each project was going to take about 3 weeks to do this. Okay, this process would take 3 weeks, and it went from 3 weeks to 3 days because you're not having to create all these views, all these sheets, drop it on the sheet, dimension it. And you could start leveraging. Now, this is like the less sexy stuff, right? It's not this cool parametric, crazy computational thing, but very, 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 very practical, okay? Very, very pragmatic. And so as it stands, a lot of us are still issuing drawings for permit and construction. And so it's just the idea of, could we start leveraging computation and automation for auto documentation? And so we could start doing this in all sorts of ways of auto view creation. If you wanted to auto document every kitchen, every bathroom inside your project, run the Dynamo script, and it'd be able to know based on the room time or have an application. You could run it, and it would be able to understand, okay, this is a bathroom, this is a kitchen. Auto document, auto dimension the elevations in every single room, and be able to drop those on sheets. So there's applications from a documentation standpoint to leverage some of these technologies as well. Now, the other one is robotics and how this starts affecting the construction process. This one is pretty cool because there's a lot of tasks that we do in construction that is very, very, very tedious. And one of those things is, say, bricklaying. And so I showed this 3 years ago, but I still think it's valid. I think they'll probably have it in the exhibit hall. I have another example, but this is Sam. This is the semi-automatic mason. And what Sam does is it goes through and lays in the bricks, and then I want you to notice that there still are workers on site. Okay, it's not replacing the bricklayer's job, but they're just doing their job faster. They're doing it more efficient, and then they can really dedicate their time to that process and really making it a more expeditious process. The other one is some researchers in Switzerland, and it's ETH Zurich University. Basically what they're doing is starting to lay out rebar, very tedious task. And could you start, not only applying this to horizontal surfaces, but very complex surfaces and complex structures. And so the idea of robotics having a place in the construction industry, not just additive manufacturing or 3D printing, but actually helping fabricate existing materials is something that I think is really, really cool. Further, built robotics, this is a newer one that had just come out in the last few years, and these are fully autonomous construction vehicles. And so you say very tedious tasks like grading, you could have some of these existing construction equipment augmented with some of this autonomous technology, leveled up with sensors, so that way if there's ever an issue, say a person or another piece of equipment comes out, it recognizes that, stops operation, and then can continue as on course. So this is Built Robotics, and they're doing some pretty cool stuff in the excavation and autonomous construction space. My father-in-law is an excavator, and he's I don't know where that's coming from. My father-in-law is an excavator, and he uses some of this kind of equipment, and it's just absolutely fascinating. So what about you guys? Okay, I've sat up here and blabbed for the last 45 minutes. What does this mean for you? How do you see this process changing your current workflow, your current practice? How are you or are you not going to leverage computational design or task automation or modular construction? What does it mean for you guys and your career and where you guys want to go? And how do you guys best prepare yourself? Because ultimately, for me, as I was thinking about a lot of this, what I don't want to have happen is the same thing that happened to me, where I was like, well, certainly this technology could never come into our industry. All this AI, machine learning stuff is for Silicon Valley and what they're doing over there in the software space, but not AEC. And so trying to best prepare ourselves and think about, okay, what could I do for myself? Or if you're an employer, if you have a team, how do you best prepare your team and stay competitive? So if you're an employer, invest in people. Find the best talent in the industry and hire them. Hire people smarter than you. I guarantee you Ben is a lot smarter than I am. That's the reason he's building out that data visualization tool. And so it's one of these ideas is you want to try to lock arms and team up with people that are smarter than you and bring them on your team. Invest in research and development. We made a major pivot this year. We're a small group, so like it's very hard. Like we don't have a lot of money to invest in new ideas, and we have to be extremely careful of what ideas that we do invest in. But we're trying to be a part of the process and pushing some of these technologies forward. And so you can start to invest in research and development at your company. If you don't, I guarantee you a lot of your competitors are. If you're an employee or someone that works at an organization, invest in yourself. There's plenty of resources, website blogs, LinkedIn Learning, lynda.com, Autodesk Learning. There's tons of classes. That's why you guys are here, is to learn. So you guys are already doing that. I think that's awesome. Learn to code, even if it's only visual programming. I can say for myself, I've gone into all these classes of, okay, write your first Revit add-in, and I go in there, and then like my eyes start glazing over, and I'm like, why am I in here? This is a horrible decision, especially after like partying all night. The night before, that probably doesn't help. Yeah, beer and code, it works too, like there's a diminishing return. Like it helps for a little bit, and then at some point you crash. And so as it relates to that, I'm digressing big time right now. The big part, what my point was, is that when you start leveraging other kinds of coding, something that really resonated with me was visual programming. And so the idea of using like Dynamo or Grasshopper, where it's less text-based, that was kind of like the gateway drug for me, where it's like, oh, this is cool, because if I connect this node to this node, it does stuff. And then what was cool is that you get kind of that immediate gratification that happens as well. It's like you don't have to write lines and lines and lines of text to get that result. You can start getting kind of that immediate result faster. Start learning about digital fabrication, robots, and data-driven design. Become the expert and bring the information back to your firm, and don't wait for someone to ask you. I remember, I can't remember, this is probably like my 10th AU, and I remember I was like, well, how come Bill gets to go to AU, and Friday night, like I was coding up something in Grasshopper when you were drinking beer and playing volleyball. You know, like invest in yourself and invest in some of these technologies because it's really going to help propel you and push you forward. And don't wait for someone to ask you. Like, just take initiative. Do it. I remember, like, I was working on this vehicular canopy, and my employer, my project manager on the project didn't tell me to use Revit adaptive components and Dynamo. Like, I was supposed to just use Revit, but like Friday and Saturday night, I was using adaptive components and Dynamo because I liked it and I wanted to take initiative. So I encourage you guys not to wait for someone to ask you, but take the initiative and start learning it for yourself. With that, I want to end on a quote. This was, I'm gonna screw up the name, but Shahjad Bhushan from Sahad Hadid Architects. He says architecture, and in parentheses is my quote. I would add engineering, construction, manufacturing, etc. Okay, so architecture, engineering, construction, manufacturing does not exist in a bubble. Robotics, 3D printing, AI, big data, and so on will have an impact on our industry. Design cannot simply be a matter of intuition when you're solving complex problems. Thank you. So for the last few minutes, I'd like to field questions. If you guys have any questions, if you guys enjoyed this talk, it would mean the world to me if you guys filled out a review. That's part of the reason we get invited back or don't get invited back is based on the review. So if you guys enjoyed this, it would mean a lot if you guys left a review. But I'd like to take the last 10 minutes or so and answer any questions. Feel free to throw rocks any of these arguments or slides or thoughts, and I'd love to answer any questions you guys might have. Yes? Real loud. Yeah, go ahead. Yeah. Real loud so everyone can hear you.
One of your slides had a button that said design to fabrication. Where is that?
The magic button, the design to fabrication button. That one was one that we were working with a client for. I can be happy to talk to you about that and how we might be able to get that introduced in your environment. But that was for a specific client. Yes, sir.
I really appreciate the comments on investing in yourself, and one of the, I think, key aspects of what you're presenting is essentially how we're presenting information. I love your slides on rows and columns are not a compelling story. How much do you look at just the field of information design and graphic design, and how, I think often we want to customize that to meet our clients' needs, and you can spend forever customizing it to meet your clients' needs.
Totally. So I'm going to repeat the question so everybody can hear. The question is, okay, rows and columns are not a good way to consume data. Graphics help tell that story. How do you do that without spending a ton of time and resources? And I think the point really being, too, is graphics in and of themselves are data, right? And so like trying to present that information, I would say what we do a lot is we build templates, and then even clients, they have certain themes. One of the mistakes that we often make in our profession is we design something and then we put our logo all over it. It's like, okay, how do you use your client's logo, your client's colors, trying to communicate design intent, but work within their graphic scheme, their color scheme, and there's a good chance that they'll probably resonate with that a lot more than, say, if you have your typical stock template that you use at your firm. Right now, we're using D3 technology as the underlay. That's really the bones of it, and Ben could probably speak to this a lot better than I could. But we're using D3 technology and using some of the Bootstrap dashboards, tying that information together, but a lot of the data is coming directly from the Revit model.
Is that pizza model available for
Yeah, do you want a pizza model? Yeah, so anybody that wants the pizza dynamo script, I'll be happy to hand that out. That's Brett Young's software, and I believe it is M2 by AI, something like MX A2, I think is what it is. Yeah, he should be here at AU too, by the way. Yeah. Sorry, can you say that real loud? Standardize the data? Yeah, for the data visualization piece, or? In general, okay, so the question is, how do you organize your data carefully? So data is garbage in, garbage out, right? So if you have bad data, you're going to get a bad data output. Formatting data is super, super important, how you group, contextualize data. We try to leverage the data in what makes sense for the process and the project itself. But I think it kind of depends. I don't know if I fully understand the question, but I think it depends on what problem you're trying to solve, and then group the data logically so that it provides a solution for the problem you're trying to solve. I don't know if I'm answering your question correctly or, okay. Sorry, can you say it just a little louder? Oh, yeah. So the question is how do you connect the data to those different softwares? I think that one I would encourage you, is Ben still here? I don't know if maybe Pablo would be able to answer this too. How you start to connect data to some of those, that's a little more out of my wheelhouse, and our team's more technical on how to answer that, sorry. But maybe one of them will be able to answer afterwards. Yes, sir.
Just wondering what, if any, insights you developed by plugging Alexa into the project. How does that interface change how you're designing, or?
Yeah, good question. So the question is how do you connect Alexa or Google Voice to Refinery, and more specifically, how does it affect how you design? Is that right? And I would say one of the things is it makes it more human. As weird as that sounds, like where I'm just clicking on a screen or on the software, I'm kind of interacting with it. And so I think it makes this weird humanization process happen of being able to interact with the software in a way that we haven't done before. And I think there's a lot of opportunities. I think we're going to see an explosion in voice technology in our industry, maybe not as much in the office, but definitely out in construction. Hey, Google, pull up my clash detection schedule for July 11th, and then it comes up on your AR headset. I could see voice, because it's so much quicker, right? Like, otherwise we're on our phone doing this, and it's that whole idea, again, guys, is mitigating the friction, right? There's friction on my phone. Even though I love my phone and it's smart and I can access the internet, it still is much quicker to go, hey, Google, pull up my report, and then it pulls it up. So I see it playing a part into that big time. Yes, sir?
Coming from a site civil perspective, so what software is out there for this multiple, for generative design, for site layout, site design?
Yeah.
Because one thing I see different is like in the building world, it's we're interacting mostly with human-made components.
Yep.
On the civil side, it's like human-made with Mother Nature. So
Oh, yeah.
there's a lot of, use your term, a lot of friction there.
Yeah.
Literally and figuratively.
Literally and figuratively. Okay, so the question is, you're from the civil side. How do we start leveraging some of these technologies, specifically computation and other tools in the civil space? Because there's a lot of building examples here, but what about in the civil 3D space? And reducing friction. Like, how do you reduce friction? And so I think the big thing is Dynamo is now available for civil 3D. So that's a big deal. So like if you want to auto model like all of your piles based on its XYZ coordinates, boom, like you can do that with Dynamo. So I think these technologies are starting to bleed over and spill over into the civil 3D space for sure. And if you think about it, I saw a tool, I can't remember the name of it, it was like 3 years ago, but you were able to optimize cut and fill. So like think about visually, like if you're changing your building on the site, and then immediately your cut and fill is like responding to that, that's pretty freaking cool. So like I think there's a ton of opportunities, both literally and figuratively, to implement in the civil 3D space. I like that. Yes?
Examples of generative design being used on the structural engineering side?
Yes. So the question is using generative design for civil 3D, or excuse me, for structural design. This is, honestly, I feel like no one is talking about this. The idea of applying, because listen, it's math, okay? It's not, is it red brick, is it beige brick, okay? It's, will the building fall or will it stand, right? And so there are calculations, we're not, like there's the formulas, the math is already there. All you have to do is plug in that data and you have that information. So you could 100% generatively model structural steel columns, bracing, beams, all of that information using the math and the technology that's there. And in the MEP, I mean, anything that's engineering focused absolutely should be leveraging this technology 1,000% more than the architects are leveraging it, because it's so scalable and formulaic and systemized and structured, no pun intended, that you can totally leverage that technology for the engineering space.
Why is it, sorry, why, like you said, it's not being talked about?
Yeah.
It's all in the code books.
Yeah. I would say people are doing, I'd say talk to Marcelo. I always goof up his last name, Scambolari. Marcelo's a structural, he gets, darn that guy, he gets Speaker of the Year award every single year, but for a good reason. He's in the structural engineering space and he's leveraging Dynamo and computation. I might have some examples I could show you, but he would definitely probably have more examples and would be a really good resource. Yeah. Oh, sorry, I think you had your hand up first.
As an architectural BIM manager looking to get into programming and custom data manipulation, would I be better served spending my time learning like API programming or Dynamo?
What was the first one you said? ABI?
Yeah, doing coding or visual programming.
You know, I'm actually going to let Ben answer this one. Ben, can you speak up real loud? And what would your advice be for someone that wants to start getting into programming? Would you recommend Dynamo or go ahead?
I would definitely recommend Dynamo because I mean that's kind of like my gateway
system, and then you kind of get an immediate response. You wanted to run it right away, so definitely would go dynamo route, and then as you're kind of expanding your dynamo knowledge, then that can lead you to like, okay, now I can start learning a little bit more about the API. I didn't know what these nodes meant before, but now, because it's kind of giving you a marketing term for that word, not a programming term, it's giving you an easier translation for it. That makes more sense to us architects having that background, so definitely dynamo.
It's good. Yes, sir.
So could you talk about investment, business leaders investment, but could you talk about the growth of your business and making that business case? Because I think there's a lot more people who want to do these things than are around them. Because you got today's work done.
Yep.
That's risk.
Yeah.
So how do you kind of run that business? How do you make that pitch? Or do you have to make the pitch anymore for everybody for that?
Yeah, so I'll repeat the question just so everybody can hear. So like, how do you convince your manager to invest in R&D? Because at the end of the day, you have projects, you have deliverables, and then more specifically, how did I apply it to my own company and be able to do that? I think, for us, we're a computational design and BIM consulting company, so in my mind, like, it's necessity, like we absolutely need and should be investing in these technologies. I can say, just from speaking, again, to share like my own failure, when I was working at an architecture company, I tried pitching Dynamo to my boss, and I was like, hey, like we need to get on the Dynamo bandwagon, and I almost swore. I felt like if I combined those the right way, I would have swore right now. I said we need to combine and get on the bandwagon with Dynamo, and his comment was, hey, we're not programmers, we're architects, okay, so don't pitch this stuff. And so like it was immediately kind of, hand to the face, not interested. And I kept bringing it up, and so I kind of persevered through it. What I would say is to try to pitch it. The thing that I've learned in my own business and as being a BIM manager at like a company is it's the people, process, technology. Process and technology, easy peasy. Like we can get that all day long. It's the human being that is the hardest piece of it. So you have to pitch it and frame it in a way that it makes sense to your company and to your company leaders. Hey, Tom, we're going to make more profit because we found a side stream of revenue that we could develop this product, sell it to our competitors or to our clients, and then we can have an added stream of revenue. And so you can pitch it as ad service, you can pitch it as marketing, but you need to pitch it in a way that it's advantageous for your leadership, not for you, not for me. Like it has to make sense to the leadership and be in their best interest. And I would say if they don't buy into it, persevere. If they still don't, go somewhere that does, in my opinion. Yes?
You answered the question here. Are you seeing any use cases in transportation?
I haven't actually, and I could see some pretty, like as you're saying that, like I'm like, oh, that's a good idea. I haven't seen use cases in transportation. I have in like LiDAR, where they have these awesome LiDAR scanners that you drive down the highway and it captures all the data. You are, but yeah, actually, Street Fit, Clifton's other tool, Ryan and those guys, like they're doing Street Fit. So they have testfit.io, which we showed, but then they have Street Fit, and they are actually doing that in transportation. I don't know why I lost that, but I don't know. So yeah, we're getting the signal now, so we got to wrap up. But I would say check out those. If anyone's interested, I have some stickers up here. If you guys want to throw a sticker on your laptop or give it to your 6-year-old, there's some stickers up here, and you can grab one of those. Thank you, guys. Really appreciate it.
Thank you.
Yeah. Thanks, guys.